This is not a story about birds. It is a story about a technology that human engineers invented in the 19th century, only to discover that biology had already perfected it millions of years ago. For 150 years, we have been asking the same question. How do pigeons know where they are? We know they can find their way home from thousands of miles away, across oceans, through storms, with no visual landmarks. We knew they had a map in their heads, but nobody could find the hardware. We looked in their beaks, we looked in their eyes, we looked in their brains. Every time we thought we found the sensor, it turned out to be contamination, or an immune cell, or a mistake. The mystery was so frustrating that one Nobel laureate famously said, if he had to choose one scientific problem to solve before he died, it would be this one. Then, in November 2025, a team led by David Keays at the IMP in Vienna finally found the smoking gun. And it was not where anyone from the mainstream camp was looking. It was not a biological compass made of iron crystals. It was not a quantum chemical reaction in the eye. It was something much more elegant. It turns out pigeons have organic wireless charging coils built into their ears. The paper, published in Science, confirms a hypothesis that was laughed out of the room when it was first proposed in 1882. The mechanism is called electromagnetic induction. And understanding how it works does not just solve a biological mystery. It reveals that the blueprint for our modern world was hiding inside a bird's skull all along. To understand the magnitude of this discovery, you have to understand the competition. For the last 20 years, the leading theory for how birds navigate was the quantum compass. This theory argues that a protein in the bird's eye, called cryptochrome 4, uses quantum entanglement to see the Earth's magnetic field. It is a brilliant, beautiful theory, but it has a fatal flaw. It requires light. If you put a bird in a pitch-black room, the quantum compass shuts down. Yet, we know pigeons can navigate in the dark. They have a backup system. A dark compass. And this is what David Keays found. The discovery centers on the inner ear, specifically the semicircular canals. These are the fluid-filled tubes that help you keep your balance. In humans, they mainly detect rotation, but in pigeons, they are doing something else entirely. Imagine a wireless phone charger. Inside the charging pad, there is a coil of copper wire. When you run electricity through it, it creates a magnetic field. But the reverse is also true. If you take a loop of wire and move it through a magnetic field, you induce an electric current in the wire. This is Faraday's law of induction. It is how every generator on Earth works. Keays and his team realized that the pigeon's semicircular canal acts exactly like a loop of wire. It is a conductive loop filled with fluid called endolymph. As the pigeon flies through the Earth's magnetic field and turns its head, the motion induces a tiny microscopic voltage across the fluid. It is biological electromagnetic induction. The pigeon is literally generating electricity from the planet's magnetic field, but generating the voltage is the easy part. Detecting it is the hard part. The voltage induced by the Earth's weak field is incredibly small, measured in nanovolts, 1/1000th of a volt. Critics argued for decades that biological cells are too noisy to pick this up. They said it was impossible to distinguish the signal from the thermal noise of the atoms jiggling around. This is where the 2025 paper dropped the hammer. They did not just propose the theory, they found the sensor. Deep inside the inner ear, the team identified a specific population of hair cells that contain a protein called Kv1.3. This is a voltage-gated calcium channel, but it is not the normal version found in your brain. It is a specific splice variant, a high-sensitivity mutant. And here is the kicker, it is practically identical to the sensors found in sharks. Sharks use these sensors to detect the faint electrical heartbeats of fish hiding in the sand. Pigeons use them to detect the voltage generated by their own flight. Evolution. Built the same machine twice, once for hunting in the ocean and once for navigating the sky. This mechanism explains everything the quantum compass could not. The quantum compass in the eye gives direction. It tells the bird where north is. But knowing which way is north does not tell you where you are. You need a map. You need to know the intensity of the magnetic field to calculate your latitude. The inner ear system provides that map. It measures the strength of the field through induction. It works in the dark. It works in the clouds. It is the perfect complement to the visual system. One is the compass, the other is the GPS. What is truly profound about this discovery is how long it lay dormant. Camille Viguier proposed this exact mechanism in 1882. He was ignored because 19th century biology could not conceive of a cell sensitive enough to detect nanovolts. It took us 140 years to build the microscopes and genetic tools capable of seeing what Viguier predicted. We spent decades looking for magnetic crystals and quantum effects, overlooking the simple, elegant solution of classical physics. So the next time you see a pigeon bobbing its head in the park, remember what is happening inside that tiny skull. It is running a navigation suite that rivals a nuclear submarine. It has quantum sensors in its eyes, reading the spin of electrons. It has induction coils in its ears, generating voltage from the planet's core. It is a master of physics, evolved over millions of years to never get lost. If this changed how you see the common pigeon, hit subscribe and let me know in the comments. I will see you in the next video.